Hello everyone, welcome to this video. In this video we are going to solve this question which states that if A is some element of a group, right, and we consider the order of A as equal to m. This is given to us, so we consider the group to be represented by this capital G. If A is this element present in G and its order is m, so that means we can write it like this: A raised to power m is equal to E, where m is the smallest positive integer of such kind, correct? And moreover we are given that if n is relatively prime to m, right, that means the GCD of m with n is equal to 1, then we have to show that this A can be written as the nth power of some element in the group, correct? So we have to prove that there exists some element P, let's call that element by P. P belongs to G such that A could be written as, I'm sorry, here we should write P raised to power n because we have considered the element to be P, correct? So here we shall be making use of this result which states that if you have the GCD of two numbers A and B, that could be written as AS plus BT, where what is S and T? These are any two integers. So for every two non-zero integers, we have two integers S and T such that you can write the GCD of A and B as AS plus BT, correct? Okay. So here, because you are given the GCD of m and n is equal to 1 because they are relatively prime, so you can write now the GCD of m and n as ms plus nt, where s and t are some positive integers, some integers in fact, not necessarily positive. So because the GCD mn is equal to ms plus nt, so this GCD mn is equal to 1. So from here you get ms plus nt is equal to 1, or you get the value of ms as equal to 1 minus nt. Why I am doing so, you'll be seeing this in a moment. And moreover we are given the order of A is m, so you can write it like this: A raised to power m is equal to E. Now you on both sides you can raise it to power s, so that the left hand side would become A raised to power ms and the right hand side would become E raised to power s, which is again E, right, the identity of the group. So now what you can do, you can substitute the value of this ms from this equation 1. So instead of writing ms, you can now write 1 minus nt, correct? So it would be A raised to power 1 minus nt. So now you can split up the powers here. So it would be A raised to power 1 into A raised to power minus nt. You can post multiply on both sides with A raised to power nt to obtain this expression. So now you have your result. Basically what we have written our A as A raised to power t and whole raised to power n. You can write it like this, there is no issue. So that we have now expressed A as some element from G raised to power n, where this element A raised to power t is definitely present in G. Why? Because A is present in G. So and G is a group, hence its powers would be present within it, correct? So we found our element P as A raised to power t such that when you raise it to power n, you get equal to A, correct? And this is what was required in this particular question. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.